The question that we are looking at is shortest path in a binary matrix. I do recommend pausing and reading the problem description first. Now, this is a classic BFS on a grid problem. Now, this path can move in 8 directions and all steps cost the same. So BFS, breadth first search, finds the shortest path. The way it works is that we start at the top left cell with a path length of 1, and then we expand outward level by level through all its 8 neighbors. The first time you reach the bottom right cell, the current distance is guaranteed to be the shortest because BFS explores cells in order of increasing distance. The visited cells are marked by setting them to 1 in the grid itself, so we avoid keeping a separate visited cell set. So let me give you a step-by-step walkthrough of this. So we start with taking out the length of the grid. The grid is always n by n, so n gives us both the dimensions. Now, before we start any work, we check that the 2 cells that must be part of any valid path, which is the top left cell and the bottom right cell. If either of them is 1, which means it's blocked, that means no path can possibly exist, so we just return -1, and that's what we are doing over here. Then we initialize directions to be all top, left, right, bottom, and all 8 directions that we are moving. And we are moving diagonally as well. So yeah, up, down, left, right, and the 4 diagonals. Now is when we initialize our BFS queue. So we use a deck, which is a double-ended queue. Now BFS needs fast removal from the top. So pop left on a deck is O of 1. So that's why we are using a deck. Now each queue has 3 things. So the row, column, and the length of the path taken to reach that cell. And we start with 0, 0, 1, so the top left cell, and a path length of 1, because the problem counts the starting cell itself as a part of the path as well. So we just start with 1. Then we mark 0, 0 on the grid to be 1, so it marks it as visited. And then we will start, so while our queue is not empty, now each iteration pulls the oldest item of the queue, which is queue.pop left, and this is the heart of BFS. And we always process cells in the order they were discovered. So we explore all cells at distance 1 first, then all cells at distance 2, and so on. So if the cell we just pulled off is the bottom right corner, we return its distance immediately. So this is why it's guaranteed to be the shortest path, precisely because it is ordered. And then over here we are exploring the neighbors. So for each of the 8 directions, we are computing that the neighbor coordinates, which is NR and NC. Then we have an if condition which checks 3 things at once. So if 0 is less than NR, 0 is less than or equal to NR, which is less than equal to, which is less than N, so it keeps the row inside the grid. We do the same thing for column as well. Now, if a neighbor, it passes all checks, we immediately mark cells as visited over here, and then we add them to the queue, and we do it over here and not when we are popping it off, because if we waited until popping, the same cell could get added multiple times by different neighbors before it's ever processed. So that's why we are doing it over here. And if the queue empties out without ever reaching the bottom right corner, the destination is unreachable, and that's why we just return -1 at the end.